So vanakkam. So we will continue our lecture on engineering seismology. So last class we have been discussing about the earthquake prediction, and we told that it is not possible to predict earthquake 100% accurately. Okay, but there are some precautions which you can use to tentatively predict the earthquake, particularly if you match 2-3 methodology continuously, and you can reliably predict a earthquake, but it's not many cases fails because of the incorrect location, incorrect time, and incorrect size. Okay, so these are all the some of the issues. And so during this class discussion on today, so there was also news. Okay, so which you can see in the screen. Actually, this is a live web news actually. So you can see that the earthquake of magnitude 4 hit Hampi in Karnataka. The another 4.7 hit in the Jamshedpur at the same time. Okay, so its news says that there was earthquake so on this magnitude and hit at Hampi and as well as in the Jamshedpur. Okay, so I am not very sure that how far these earthquake reports are right, because many times since there is a poor seismic instrumentation and then many vibrations which are caused by the any other human activities are to be considered, or people believe that that is an earthquake. So let's see the IMD website, official website. This is actually Indian Meteorological Department website. So what was the last update was given was that actually about okay, so this was today morning. Okay, so not today morning 10:47 was the last update. So if you see the different earthquake which is reported basically, so okay, I think that there was an issue with the screen. I can reduce the size. Okay, so now it is possible to see. Okay, so there is one earthquake. So then there is a Chenabarji, Meghalaya, there was an earthquake. So it was around 1:43 early morning. So but that report what we have seen, okay, it shows that there was about 6:55 in the morning. There was a 2 earthquake in the one at Jalandhar, Jamshedpur, and another was in the Hampi. So I am not very sure, there is no such any records are reported here. Okay, so there is no such any records are available. So maybe I think this we have to check really the seismological data. So you can also see that they are given a Richter scale. Okay, 4 on Richter scale and timing. Another is the magnitude of 6.4 on Richter scale, again they are given. So since the sizes are very small, so the Richter scale will be more accurate. So but again there is a doubt it is earthquake or not, which maybe you can explore. Okay, so because right now I am not very sure I can comment about that without seeing. Let's see the geologically where these areas are located. Actually the Hampi is located on this place. Basically this is the Hampi. Most of you may be knowing it is almost like a center of the Karnataka, even here southern India you can say. So the Jamshedpur is here, this was somewhere. So both the regions actually in the peninsular India, but both of them very far. Okay, so there is about 1600 kilometer far roughly. Okay, so 1500 kilometer roughly far. So I am not very sure there is anything linking between these two. One can expect that the earthquake may be happened kind of things. Anyway, you can explore that what happens and about this report, and by the time it will be clear, today evening or tomorrow there will be officials, they will be issuing the warning or the notice saying that it is true or false kind of things. And we also should remember that what are the seismic station nearby. In case if we have the seismic station very far, for example if there is no station around 100 kilometer from these regions, it is very difficult to record a lower magnitude. Okay, so that is also one of the factor we should consider. It doesn't mean that all IMD website reported is right, because we have seen that they have station capacity at different part of India, depends upon their radius, zone and instrumentation type and all, which nearly we have to consider. Okay, so let get back to the business. Okay, so what we have been discussing actually the earthquake hazard. Okay, so prediction. okay, because earthquake prediction it is not possible, but the earthquake hazard can be predicted. So, why we need to predict earthquake hazard and how it is represented. So, as I told you that even though this prediction, okay, so the prediction will help you to get some of the information about the earthquake, but that will not help to 100% reduce your damage and loss due to the earthquake. So, how do you reduce the damage and loss due to the earthquake? By proper prediction and mapping of earthquake hazards. So, how do you map and predict earthquake hazard? So, that is what we are going to discuss in the couple of classes from now. As we have seen that, okay, the time domain and frequency domain parameter, duration, these are all the important parameters which are required. So, estimating of this based on the past earthquake will help you basically to design your structures for the future. Okay, so, even the past data will be sufficient at least to avoid a collapse of building. Okay, that is what you can see. This is the known history of the earthquake in the region will be sufficient to consider to avoid collapse of the building. If you want to go for more accurately, you can predict hazard for the future. So, that is the prediction of earthquake hazard. So, this earthquake hazard prediction not everybody can do, because you need a scientific knowledge and background and then analysis skill. So, because of this, okay, so there is a agencies, okay, or a institution which is controlled by the government. Okay, a government himself set up a committee to do this process and release a map. Okay. So, that kind of map is called as a seismic zonation map. Okay. So, the seismic zonation is actually, so okay, the zonation is basically grouping the area, okay, so by similar seismic activity. The seismic zonation means you are preparing the map, okay, so showing the seismic potential of the region. Okay. So, today class we are going to talk about what is meant by zonation, how different level it is done, okay, what is the correct way of zonation, doing the zonation we are going to discuss in the today class. So, as I told you that since earthquake hazard prediction is not possible for all the level of earthquake, so it is better to go for the predict hazard at throughout the country and inform to the people, okay, then so that people will consider that for the design in the this one. So, the process at which where they prepare a map kind of things for the different earthquake hazard parameters is seismic zonation and seismic microzonation. So, we are going to discuss about that. So, the seismic zonation may be termed geographically a delineation of area having different potential for the earthquake hazard effect. So, earthquake hazard effect, what are the earthquake hazard effects we have seen? So, we have seen that the ground shaking is one of the earthquake hazard effect. So, telling how much ground going to shake. So, ground shaking can be represented in the time domain parameters of acceleration, velocity or displacement or duration. So, these kind of parameters, mapping them and telling in the geographical form and delineate the similar values, call it as a single zone, is called as a seismic zonation. So, seismic zonation can be done at a different scale, okay, national level, regional level, local level and site level. So, what is the national level? The entire area of India can be considered as a seismic zoning area. You can adapt. So, when you consider larger area, the minor information what you are going to consider will be reduced. So, that kind of larger area is a national level hazard prediction. But the larger level hazard prediction may not be very accurate. Sometimes the variation in the geology and seismotectonic and the seismic wave propagation at a particular location will be missed. Okay. So, that level, the regional level zonation like a district, okay, state, those are the regional level seismic zonation. So, even if you do the regional level seismic zonation, that may miss some of the issues. So, for example, the entire Karnataka state, okay, so the south Karnataka like Bangalore, Mysore, this falls on some geological formation. So, the north Karnataka, Hampi and then the other places, this falls on the different geological formation. So, that case, so that local level variation may not be even accounted in the regional scale. So, that to account you can go for the local level. Okay. So, like microzonation of city or zonation of city kind of thing, and the site level. Okay. So, like within a Bangalore, so IISc camp, okay, the IISc campus, and then the electronic city may behave differently because of the structure and then the geological formation and the people in that area, building type. So, this is to be considered site level. So, that kind of variation we have to account. The term zoning implies that the parameter or parameters that characterize the hazard value a constant value in each zone. So, you can group them into different zones, and then wherever equal values are, that is a single zone. For example, for practical reason, the number of zone reduces 5 as in the case of large majority of national code. We obtain a rather simplified representation hazard which relatively has continuous variation. So, you should delineate means you should not delineate with the 25 zone, 20 zone, it should be minimum number. Okay. Generally 5 is the common smallest and biggest number they adopt for the zonation purpose throughout the world. Okay. A seismic zone is region in which the rate of seismic activity remains fairly constant. So, if somebody says that the 2-3 area in the seismic zone, okay, number same zone, it relatively behave a same manner. Okay. A seismic zone is region in which the rate of seismic activity remains fairly constant. So, this means seismic activity increasingly rare and extremely common. Some people often use the seismic zone to talk about the area of increased seismic risk activity. So, seismic zone is different from the seismic risk. Okay. So, for example, people believe that India, we say that India is actually 4 zonation right now. So, the highest zonation in the Himalayan belt region. Okay. So, people believe that because it is very active and high zone, they think that that is a seismic zone, and Bangalore, which is seismic zone 2, they believe that Bangalore is not a seismic zone, because they interchangingly misunderstand a seismic zone and seismic risk. Okay. The highest zone will have the highest risk. Okay. If the peoples are prepared for that, it may have the lowest risk. It does not mean that you should always have the highest risk. The lowest zone may have the highest risk or lowest risk, it depends upon the people preparedness, construction, and the magnitude of earthquake, place, lot of things which covers, which we have discussed, all the wave propagation, all those things. So, people will interchangingly use, but hereafter you should not have that kind of confusion. The seismic zone means zone which represents a seismic hazard in that area. Okay, the similar exposure of the hazard in that area. So, that is the seismic zone. So, many nations and government agencies concerned with the seismic activity, because as it is not predictable, many people die. We have seen that the lakhs and thousands of people die every year due to earthquake. It is irrespective of the the economic status and education, all those things. Only thing we observed that the developed countries damage will be 1% lower than the damage caused by in the developing countries. Okay. So, that was we have seen, that is due to the preparedness and structural resilience, all those things. So, the government generally will concern about that. So, they prepare a zonation map and tell people that this is the zonation of the country. You design your building or take care yourself to live in this area. Okay. So, these agencies uses data as they collect from the seismic activity, divide the nation into various seismic zone. So, generally the government involved on preparing seismic zonation map. A number of different zoning system are used, from the numerical zone to the colored zone, each number and color representing the different level of seismic activity. Okay. They use a numerical number or Roman number and with color coding. The seismic zone for engineering use is a map that specify level force or ground motion for the earthquake resilience design and thus different from the seismicity map which provide only the occurrence of the earthquake. So, here we are going to differentiate the seismic zonation map, okay, then seismic zoning map, what engineering is looking for, okay, seismicity map. Okay. So, if you look at the different map, okay, so as I told you that, so this is my area, okay, so I can prepare a different map. Okay. So, one is that I will make this area divide as a different zone, okay, zone 1, zone 3, zone 2. Okay. So, this is the zonation map because it implies what is the seismic zone, equally behaving areas are given. Okay. So, this is the seismic zone map. So, the same map, this can be general useful to know that which area is more dangerous. As per this map, the area zone 3 is more dangerous than a zone 1. Okay, that is the one. So, but engineering people may not be knowing the more or less, it only common people use. Okay. So, somebody want to start a business. Okay. So, then he will try to prefer a places where less risk. Okay. That is the one thing. Or somebody want to set up a chemical factory. Okay. So, that is government will choose a land for selecting that. So, they go for the less risk area. Okay. Like that it is useful. But engineers may not be only convenient with that because they need a seismic values, hazard values which is useful for design of structures in the region. So, what are the way you can consider the hazard value? So, time domain parameter, frequency domain parameter, like you need to give a PGA, peak ground acceleration, or PGV, PGD, or the spectral acceleration with the time. That is what we have seen from response spectrum. Okay. So, these two parameters has to be mapped and given as a zonation map. So, that is what engineering requirement. Okay, that is a zonation map. But these two map should not be confused with the seismicity map. What is the seismicity? As we have seen that seismicity is spatial distribution of past earthquake. For example, somebody say that seismicity means, okay, so they can say that so here I will give you a legend. So, this is like less than 4, so 4, 5 to 6, okay. So, this is like more than 6, something like that. So, I am representing the seismic history of the region or seismic event reported in the region. This map is called seismicity map. So, people should not confuse with the seismicity map with the seismic zonation map. Seismic zonation map may not a seismicity map. Okay. But seismicity data may be useful to arrive the zonation, but seismicity maps are different. So, now you understand what is the seismic zone, what is the seismic risk, what is the seismic zone recorded by the map recorded by the engineers, and what is the seismicity map. So, this is made you very clear to understand the earthquake related activities or earthquake related this one. Okay. So, there should be clear understanding between these maps. So, let us see. So, the task of seismic zoning is a multidisciplinary activity which involves the best input from the geologist and seismologist and geotechnical and earthquake and structural engineers. So, the zonation map of any place should be prepared by consulting all these people. Why you have to consult all these people? So, we have seen that the geologists know to do a seismic source in the region. Okay, that is what seismic source characteristics, source related study will be obtained from the geologist. So, the seismologist basically get a past earthquake data in the form of isoseismal map or earthquake recorded data that they will give. So, the geotechnical engineers, okay, so the engineers will basically try to understand when wave propagates, okay, how the different layers of the earth will going to behave. So, that is why the geotechnical engineers are very important. So, the other earthquake engineers basically will try to estimate a hazard, okay. So, and try to predict a probability occurrence of that hazard. That is why earthquake engineers are important. Okay. The other engineers, structural engineers, all this data whatever you give, how the structure will perform, how I can consider these forces to reduce my structural failure. So, that is what structural engineer does. So, all these people together should work, okay, or the knowledge of all this information should be gathered together and incorporated in the preparation of seismic zonation map. So, the preparation of seismic zonation map is a very important part, as it gives useful data for the future settlement and then disaster management and lot of things. Okay. So, why we need a seismic zonation map? So, the seismic zonation map of the country is a guide to show the seismic status of the region and its susceptibility to earthquake. Okay. By knowing the seismic zonation, one can believe that we are living in the high risk area, low risk area, intermediate risk area, whatever, and then how this area is susceptible for the earthquake. Like by knowing the zonation, you can know that if the zonations are very high, so there is a more possibility of getting the higher magnitude of earthquake and seismic forces or seismic events in the particular place. Okay. So, that is the information we will get, and this city and regional planning considering the different earthquake hazard. So, city planning and regional planning. So, the planning stage, okay, we need to know some of the facilities where to kept. So, what is the city planning? So, generally in India city not planned actually. With the time city are growing, that is all. There is no planning kind of. What is the city planning? For example, in particular city where I should keep a secretary office like government secretary office, where I should keep locate a hospital, where I locate a police station, where I locate a the factories, okay, particularly hazardous factories like chemical factories, gas filling stations, okay, all those things there is a some kind of guideline. So, you should locate only on those places. So, that kind of planning, okay, regional planning it will help, okay, city planning it will help. Then regional level, so where I will construct a dam, where I will construct a nuclear power plant, okay, where I will construct a multi-facility hospital which is larger scale handle a population. Those kind of information will be city and regional planning. So, as on now India, I do not think we go by anything this. So, how the zonation map will help? For example, the seismic zonation map of prepared for the Bangalore. Okay. So, as such we have like already station hospitals are located, I am not talking about that, we are going to. So, by looking at the this map, okay, so this region entire Bangalore region is basically divided as a 3-4 zones, okay, like this. Okay. So, there is a one zone, then like another zone, something like that has been prepared. Okay. So, this will be the zone 4, zone 2, okay. So, zone 2 and zone 3. So, the city planning means generally the emergency services, okay, are the very important services. What are the important services? At any cost the administration government should work. So, the secretary facilities, that is a very important. At any cost law and order should work. So, those are all the things are very important. At any cost communication should work. Those are all the things are important activity. At any cost fire things are should work. At any cost hospital should work. So, these are all the important facilities. By planning the city, you can try to avoid high risk zone. You try to avoid this. So, you try to move this place, this place. So, it is not depends upon the people need, it depends upon the seismic risk. Okay, you should locate accordingly. Okay, that is the where you will plan. Secondly, like transportation system like that. So, you can scale up the facilities and importance. For example, the army camp. At any cost, the army camp should not be suffer due to earthquake. So, you should locate them in the safer places. Okay. So, that kind of planning will help. Okay. This kind of planning will help. Then the hazardous sites. Hazardous sites means like a nuclear disposal site, chemical factories, okay, the gas filling station. This should not be kept where high seismic risk area, because sometime the earthquake occurs, these failures of this causes a fire, flood, unnecessary issues which is worse than the, okay, the actual earthquake itself, because that kind of things will be minimized, okay, when you do the this kind of this one. And then the seismic zonation map also should provide input for the design of normal buildings in the region. So, not special building. Why I am saying normal building? Because the country level or regional level or city level mapping considers a large area. You cannot confine a small variation in that. So, in that case a normal guideline for the routine building. So, routine building means the ground plus 1, ground plus 2, something like that. The special building means like 1000 people, 2000 people stay in that same place, okay, multi-story apartments. Then the hospitals, okay, then the chemical factories. So, these are all the special buildings where a site specific condition has to be considered to design. Okay. So, those area to identification, all those should be done in the zonation map. For that you need a zonation map to locate and also know that you are in lowest seismic risk zone, highest seismic risk zone. So, these are all the information where it will be useful basically to get to know from the seismic zonation map. So, this is the importance of the seismic zonation map. So, what are the ways the seismic zonation maps are done? So, seismic zonation maps are done, okay, at a different scale and level. Okay. So, what are those different scale? So, the seismic zonation, okay, the types of seismic zonation is defined as a 3 major category. Okay. One is that macrozonation, okay, microzonation and nanozonation. Okay. So, this is basically gives a scale. So, the macro means the zonation which is done at a larger scale. Okay. So, for the larger area like country or continent, okay, the macro level is adopted. Okay. So, the microzonations carried out considering the seismicity and geology. So, macrozonations are basically carried out by considering the seismicity and geology, larger scale input without considering the geotechnical aspects. So, that means the wave propagation consider based on the approximate geology of the region and the seismicity of the region they will do. So, this kind of this one preparing the seismic zonation map of India or Asia, okay, or Asian continent, Australian continent, America. So, they do the macro zonation. Okay. So, the microzonation means micro level. So, where they try to put information on the wave propagation, basically all the damages controlled by the wave propagation, they try to adopt a regional level recorded data or seismicity, try to understand how the wave propagations are happened, try to incorporate, okay, the geology, geotechnical and local soil condition, how it modifies the waves. That kind of consideration is given in the microzonation. Okay. So, the nanozonation is generally done for a typical area or place like army camp, IAC camp, something like that, where a confined area for several acres. Okay. Those kind of things is called as a nanozonation. Very smaller scale map hazard, people they even consider a building type and risk associated with that, so that it can be damage can be minimized considerably. Okay. This is the 3 type of seismic zonation. So, the seismic zonation is also depends upon the type, the scale what they adopt varies actually. So, what I am discussing here is actually published by the ISMGE in the international workshop. People discussed and finalized the scale at which mapping has to be prepared, but this is slightly old actually, because now because of the improvement in the electronics and mapping tool and all. So, you can even go for the very low level gap, lower level scale even for the, but the minimum. Okay. So, basically a macrozonation will be done considering the scale of 1:10 lakh, okay, or 1 million. So, the microzonation is considered a lower scale. Okay. So, then but it is done at 3 level. What is the first grade, second grade and third grade microzonation? First grade means map can be prepared at a scale of only 10,000 to 50,000. The ground motion was assessed based on the historical earthquake and existing information of the geology and geomorphological map. They do not do any detailed investigation or analysis to get the data. Okay, so that was this. Okay, this is called as a first grade. So the second grade is where they prepare a map 1:1 lakh to 1:10,000. The ground motion is assessed based on the microtremor and simplified geotechnical studies. So we will be discussing the microtremor. Microtremor is basically, so as I told you that seismic record. Okay, the seismic record you get, no. So if you get a seismic record, you get the recorded earthquake data. But in all the places you may not get the recorded earthquake data because the earthquake may not happen. So people, scientists come up with the concept that the seismometer can be used to record vibration at a particular place. That vibration can be taken up and used for getting the ground waves, how it propagate at a particular place, particularly by knowing the predominant frequency of the ground. We have seen the fundamental frequency, natural frequency. No? To measure those values, the microtremor surveys are used. Okay, that is why you should use microtremor and geotechnical way. So you are not modeling, only measuring those kind. The third level is 1:25 or to 1:5,000. So this prepared a scale round assess the based on the complete geotechnical investigation and the ground. So here they try to model wave propagation very accurately, try to predict how the waves will get changed. Okay, try to predict how the waves are getting changed. Okay, so how the waves are get modified or reduced or increased. So that is in the microzonation level 3. So the nanozonation generally done nano level where the scale will be less than 1:5,000 for seismically very active region or important structures and facility. For example, setting up a nuclear disposal site, setting up a nuclear testing reactor, okay, setting up a huge dam. So these are all the information required a minor level wave propagation at the site. Okay, because the dam, these sites are few acres, okay, like maybe 100 acres, 200 acres, not a very big level. So that kind of places you need a nano zonation. So the component at which the seismic zonation is done basically, so they try to estimate a source effect, okay, the path effect and the site effect. Okay. So three of them clubbed together, and the microzonation is defined as a zonation with respect to the ground motion characteristics taking into account of source and site condition. Okay. That is what defined as a microzonation, which is defined by ISMG Technical Committee 4, which is committee responsible for earthquake geotechnical engineering and related studies during 1999. So this definition, okay, so any region which divides, okay, the region into different zone considering the source, path and site modification or effect of the wave how it propagates is called as a seismic zonation. Seismic microzonation depends upon the scale what you adopt. So the microzonation concept is the origin for developing a seismic zonation of the each country. As I told you that each country will release their own seismic zonation map. Okay. So then that zonation map will act as a input for planning, okay, then execution, construction, all those things for the normal buildings. Okay. The special building one has to do their own studies. We will also discuss about the Indian zonation map, what is the advantage, limitations in the future classes. So we will continue a microzonation concept in the next class. Okay. Right now we just talk about what is the zonation, okay, what zonation must have, why we need to do the zonation. All those aspects we have discussed. Next we will see how we can do a better seismic zonation. What is the methodology we should adopt in the next class. So thank you very much for watching this video. So we will see you in the next class. Thank you.